In this video, we will look at one-sided limits. As we approach a value x of a function, we may notice it behaves differently from the left and right directions. A right-hand limit is written as such. The limit as x approaches c from the right of f of x equals L. X approaches c with a little plus sign means from the right-hand direction, and that means we will consider only values of f of x for x greater than c. Well, on the other hand, we also have a left-hand limit. The limit as x approaches c from the left of f of x must equal some value we'll call m. And x approaches c with a little minus sign, of course, means from the left-hand side. It means that we will consider values of f only at x values less than c. Let's take a look at an example. Let's say we have a picture of the following function. Let's take a look at a bunch of different limits as x approaches different values. So the first one says the limit as x approaches 0 from the left-hand side. You can see our function isn't to the left of 0, right? So our function does not exist there. So our limit does not exist. However, let's take a look at the limit as x approaches 0 from the right. So as I'm going in this direction, right, towards my 0 from the right-hand direction, you can see I have y value 1. And the limit as x approaches 0 of f of x, we also say is 1, and I'll note a little bit more about that in just a minute. Let's take a look at the next set of examples as x approaches 1. So the limit as x approaches 1 from the left, all right, so now we're going this direction, right? Our y value is going to be 2. However, when I approach 1 from the right, so the limit as x approaches 1 from the right, we're headed in this direction, and we can see our y value is going to be 1. And then we say the limit as x approaches 1 of this function does not exist. And again, I'll say a little bit more about that in just a minute. All right, last set of examples. Let's look at seeing what's happening at 2. So the limit as x approaches 2 from the left-hand side, so now I'm going in this direction, right? So as the limit approaches 2 from the left, my y value is 1. All right, and now next, the limit as x approaches 2 from the right, so now going down in this direction, we see it is also approaching y value 1. And so we say the limit as x approaches 2 of this function is 1. All right, so let me add a little bit about a couple items I kind of breezed over. All right, this first one is the limit of f of x as x approaches 0, I said is 1. And that is because I said in our domain, right, there's no part of our function less than 0. So I have a little note. It says at a boundary point of its domain, a function has a limit when it has an appropriate one-sided limit. So that's why we say the limit as x approaches 0 of the function in this example is 1. All right, the second thing I might have breezed over just a bit is this one right here. The limit as x approaches 1 of f of x, we said does not exist, all right? And there's a reason for that. And I have the following definition. It says the two-sided limit as x approaches a of f of x exists if and only if when the limit as x approaches a from the left is equal to the limit as x approaches a from the right. So again, a two-sided limit is only going to exist if our one-sided limit is the same or equal to each other. So we can see in that previous example, all right, the limit as x approaches 1 from the left was 2, and the limit as x approaches 1 from the right was 1. So those two values are not equal to each other, so we say the limit as x approaches 1 does not exist. All right, next let's take a look at limits that we call towards infinity. So we say the limit as x approaches a of f of x is infinity if f of x grows without bounds. So x just keeps on getting bigger and bigger and bigger, and we can say the same thing if it were negative infinity. But wait a second, infinity is not considered a number. So our definition says that a limit exists only if it's equal to some value or number. That means we have an important distinction to make here. So, quick little fact, infinite limits do not actually exist. That is saying the limit as x approaches a of f of x equals plus or minus infinity is just a more specific way of saying the limit as x approaches a of f of x does not exist. And we always want to be as specific as possible. So we have to be careful of that. Again, I just have a little warning explaining that in further detail if you would like to take a look at that. So let's take a look at one more example, and that involves that infinity. All right. And so we have the following function. And let's take a look again at just a bunch of limits at different x values. So first one says the limit as x approaches 2 from the left. So let me change colors real quick. So we're going in this direction. Right, and as we're approaching 2 from the left, we can see again my y value is 1. However, when I approach 2 from the right-hand side, all right, we can see my function is actually approaching y value 2. And again, we'll notice the limit as x approaches 2 of f of x. So again, my left-hand limit is not equal to my right-hand limit, so I must say the limit at 2 does not exist. All right, let's take a look at the next value of negative 2. We see the limit as x approaches negative 2 from the left, my function's increasing forever, and so we will just call that infinity. And then the limit as x approaches negative 2 from the right-hand side, we can see we are decreasing forever, and so we would call that negative infinity. And we'd say the limit as x approaches negative 2, again, my left-hand limit and my right-hand limit are not equal. We would say this does not exist. All right, last set, let's take a look at what's happening around x value 7. The limit as x approaches 7 from the left-hand side, we see is decreasing forever, so we would say this is negative infinity. And the limit as x approaches 7 from the right-hand side is also decreasing forever, so we will say that is negative infinity. And so we see the left-hand side and the right-hand side limits are indeed equal to each other, so for all intents and purposes, we would actually say the limit as x approaches 7 of this function is indeed negative infinity.